Thank you very much. So, hi everyone, I'm Daniel, and this is the GPU day, right? And it's about the cutting edge, the latest of the latest. And we have heard about AI and AI and AI and AI and quantum computing. But let's put GPUs back into GPU day, shall we? Okay, so I'm going to talk about the latest GPU technology that is interesting, I hopefully not just to me, but to others. And this is WebGPU. And I hope I can convince you that it might be interesting to you too. So let's see what this is about. Why do we need yet another API? Especially on the web. So, we are not writing assembly on the GPU. We are using some high-level languages and programming interfaces to give commands and data to the GPU. And our options are depending on what the vendors and software companies are giving to us. The problem is, yes, I went too. So the first thing is about graphics. GPU is about graphics, right? So what do we have on the web already? I think you mostly see images, like opening a web page or putting one together. You might want to put up some nice images. That's fairly trivial. Then there is CSS. If you work with it, you know that. If you don't, good for you. It's a nightmare. On the other hand, we have the HTML5 canvas that's reasonably good, and you can do 2D graphics with it. That's fine. But if you want to go for 3D, some interactive visualization, something like that, we basically have WebGL and WebGL2. And that's what we have. And the problem is that these are old, okay? And they are coming with problems. And there has been a long list of attempts to replace them or improve the quality of life of 3D graphics and also computations on the web. And they did not turn out to be useful or widely adapted. So the new thing is yes, yes, yeah. Of course, there are high-level technologies, but the question is what is underlying, because everything else is building upon that. Yeah, the question is good. Yeah. So we have WebGL and WebGL2, but they are built on the legacy OpenGL chain of technologies. Let me remind you that OpenGL was established somewhere in the beginning of the 90s. And last time I checked, it is 2025. Okay, so it's already quite old. It's an implicit state machine that is the worst abstraction that you can have in a multi-threaded environment. And it only supports basic programmable shading, vertex and fragment shaders, no general compute. And these days, everyone is trying to run large language models, neural networks, and all that stuff everywhere. And it's just a nightmare if you want to implement it over this technology. And the problem is, so it doesn't fit the existing hardware, so it's going to be hard to get the best out of the GPUs that you can buy, and it basically translates to driver overhead, and you won't have access to the newest feature. So it's not really good. The solution, and this is the same problem that desktop graphics had 10 years ago, and they did solve it by going to lower level technologies and a more modern design. So the solution is the same here, and this is WebGPU. So it recognizes that there are newer challenges that we want to do. We want to make nicer games, even on the mobile. Most people are gaming on the mobile nowadays more even than on the computers. And we also want to do some advanced visualization and, of course, AI everywhere. So we want to do all of these, and there are quite powerful GPUs in your mobile phone or in your tablet and other devices. But there is the constraint of energy efficiency, not just because of battery life, but also you don't want to hold 500 watts of radiation, heat radiation in your hands because that's not really comfortable. So we want to go for more energy efficient solutions. And this is, again, going to be a lower level access. And it's not just about graphics. We want to do all this general compute for neural networks and AI. And this is a big driver of all the innovation that is going into this technology. And the other aspect is that, yes, this is web. Web is coming with lots of extra requirements over the top of the technologies that we usually work with on the desktop. It's about stability. You cannot just crash randomly here and there. You cannot just have all kinds of memory problems. That's not going to work on the web. And also security. I'm going to talk a little bit about that. Okay, so we want to go low level. How low level? How is this going to be implemented? So as I said, the answer is already there. We have low level graphics APIs. On the Windows platform, we have DirectX 12. On Apple machines, we have Meta, and everything that is non-Apple is basically capable of running the Vulkan API by the kernels consortium. And basically, all these three are allowing you to access the latest features of the GPUs with very, very little driver overhead, so very efficiently. And they are actually quite similar to each other. You can actually implement Vulkan over Meta. You can implement Vulkan over DirectX 12, and maybe also other combinations can be implemented on each other, so they are similar. So WebGPU is trying to hit a middle ground between the complexities. So OpenGL is quite easy. You can get started reasonably easily, but the other APIs are very low level, meaning you need to write a lot of code to get something done. And WebGPU is not exposing everything. It would be a nightmare for various reasons. It hides many of the synchronization and queue management, memory management, and some presentation details, but it exposes the basic object, the pipeline object that is describing the state of the rendering pipeline, rendering setup, and exposes the construction of commands that is the main driver of overhead in the processing. So just for illustration, if you want to do some very, very simple things, drawing a simple triangle on the screen, in Vulkan, you need to type out roughly 1,000 lines of code, so it's quite demanding. In WebGL, it's a little bit over 100 lines, and WebGPU is comparable in the amount of lines of code that you need to write. You cannot do arbitrary computation in WebGL, as I mentioned, but you can in WebGPU, and it's not much more complicated. While again, if you want to do the same thing in Vulkan, it will be more than 2 times of that. So it roughly translates to the mental overhead that you need to learn and think about when putting together something in the low-level APIs, but it's much easier in these higher-level APIs. I will talk a little bit more about that. So the big question is that I know most of you are not developing for the web, right? So you might ask why the hell I should care about this thing. And the answer is, on one hand, if you have ever tried to do cross-platform graphics, right? Linux, Windows, Mac, your Android device, if you have ever tried to do anything that works on all of them, you know that it's always a nightmare. So now there is going to be an opportunity, a new opportunity to do something in this regard without using some very large, complicated systems that could handle all of this for you. So WebGPU is not just for the web. So don't stop there, because it has bindings for the desktop market too. Basically, what happens is that the companies who are building the libraries used inside the browser are also open sourcing it as a library that you can link to in your desktop applications. So basically, if you have a C++ or Rust project, you can easily just pick up the library, the same library that is running inside your browser, to do something within your application. that would not run directly on the web, perhaps, but on your desktop system. And in other direction, you can also just write a C++ project and directly compile it into a web application using the mscript and toolchain. So there are various opportunities, and it's really easing the pain of developing something cross-platform. But besides that, we have this big problem that today, if someone is trying to get started with modern graphics, we had the problem of answering the question, which API to start with. Because if you start with something simple, that would be OpenGL, but that will require you to unlearn many things later, and that's not really efficient and would drive people away. But on the other hand, starting with a low-level API is, let's just say, extremely challenging. I know some of the technical universities are pushing the students into starting with Vulkan, but that's actually quite frightening. So WebGPU solves that by hitting a middle ground, and I would say in complexity, it's much closer to the OpenGL toolchain. And the other thing that it solves is it requires zero setup. Basically, all of the devices that you are using are coming with a web browser, right? You don't need to set up. It's going to work just out of the box. And it would mean that the WebGPU would work there also. And besides that, you just need a text editor, and that is quite abundant these days. So if you do work with web technologies, or you actually would like to do something on the web, then the other selling point is really compute shaders, general compute. Whatever you are used to doing on the GPU, doing whatever arbitrary computation, there is a new window opening that you can actually now do it on the web, within a browser, within any of the devices that support it. Besides that, it would bring faster rendering and more features, more access to the low level and the newest offerings of the GPUs powering those devices. And this is going to be actively developed, because you might know that the OpenGL development has basically stopped. They are not shipping any new features there. So yes, this would sound very interesting, but of course there is no free lunch. There is some compromises in the background, and not everything is as easy on the web than with the native technologies. The most important thing is security. As I mentioned, you need to bring a solution that is reliable and would work with the extreme requirements in the browsers regarding isolation, stability, sandboxing, separation of memory spaces, and all that thing. And they take it very seriously, and it's a trade-off against performance. So WebGPU might not bring out 100% compared to the native technologies, but let's say it's in a single-digit percentage of losses. And the other thing is that it needs to support a much wider range of devices. Just think about it, how many different kinds of mobile devices are there compared to the desktop systems. It's a quite wide range, so they might have very, very different capabilities. So there might be a compromise in the features that you might want to access. And also the other thing is on the web, everything is about data, your data that everyone is interested in. And there are some limits of what you can query from a device, because that could be used for fingerprinting. And not everyone is happy with that. If you're a scientist, you could also ask, why should I care about it? And if it is good for your application in some sense. And one big minus is that currently there is no double precision support, and it's not planned for the initial version. There is a popular request for that, so later it might be considered, hopefully. Of course, there are devices out there that might not support double precision, so you might not be able to run very precise simulations there. However, if your topic would need some advanced visualization, with very large data sets that would require, for example, interactivity, then WebGPU would be a good solution there. You would be able to render much larger and more demanding, more complex geometries than before. And as I mentioned, we see some added value in educational approaches. So currently, if someone is asking the question what to learn first, I think we would tell them to look for WebGPU. And there are some directions that it might be also adapted to the augmented reality and virtual reality devices that would also be interesting. And yes, you can write some nice particle simulations still that would not require double precision. And there are also opportunities in doing client-side computations. So remotely accessing some data and post-processing it on the device that you are working with. Okay, so I talked a little bit about the motivation, but basically WebGPU is just another GPU API. It has the familiar building blocks. It's some API object that represents the physical GPU. It has a command queue where you can issue all the operations that you want to do. It has buffers, it has textures, it has shader objects that you create from the text file sources. These are representing your shaders or compute kernels. You write those in a shading language called WGSL. And the most new things around these pipeline objects and resource bindings and command buffers, I'm not going to talk about them. There are many demonstration codes around. I also going to link a few at the end of the presentation. It's not really, really complicated. They have decided on their own shading language for various reasons. It's a plain text format. You can write some commands in it, and that is going to run on the GPU. It's portable across all platforms. That was the biggest challenge that was solved here. It's a little bit Rust-like that few people have different opinions on it, but this is now the thing that everyone is happy about what is modern. And it's somewhat restricted in some senses, but functionally similar to other shading languages, GLSL or others that were around before. And the new thing here that is complicating a little bit things that you need to explicitly manage your bindings. I'm going to show you just a very, very simple demonstration, adding two vectors together element-wise and writing the result out. You need to manage these binding indices that uniquely represent which buffer is bound to which location and how they will be used. Read-write access is required into them, and otherwise it's just the C-style declarations of types and the same code that you would otherwise write in all of the GPU APIs. So it's not that different. So you might ask that I've listed many good features. The question is it already heaven on earth? The problem is it's not yet. The specification is still being developed, so it's really the cutting edge of the technologies. It's not yet finalized. It's now in the W3C candidate recommendation status, so it has some way to go before it gets accepted, but there is already preliminary support. Google is the biggest company who is pushing this. There is already support in the Chromium-based browsers. So if you have Google Chrome, Vivaldi, Opera, and a few others that are using the Chromium engine, like Edge on Windows, you are already able to run WebGPU codes. And the other browsers are already working on it. They have experimental support. That means that you need to go to some deeply hidden settings and you can enable it. Both on Safari, on iOS devices, or Firefox. They are working on it. It's just not ready. There are examples and all kind of documentation, but it's somewhat rare and sometimes it's out of date because that's the latest, the newest. Everything is changing very rapidly, one week to the other. So it's very hard to, there are sometimes the sample codes out there a little bit out of date, but it's still okay, and you can usually with small changes you can make it work. So will it stay? As I mentioned, there were many attempts before, many different working groups tried to push compute to the web or other advancements, and they have failed before. It looks like this one will stay. There is quite big industry push behind it because of AI and games, and really deploying some neural network or large language model to be run on inside the browser is quite challenging because the underlying technologies are not modern enough and not working that well, and the WebGPU is going to solve that. So as I mentioned, there is big industry players behind it, and there are just enough implementation that is going to be made sure soon that it's hard to imagine that is falling out and not happening. There is no alternative right now. Okay, so I'm linking here some reading specification documents, sample codes, whatnot. I have also put together a few different sample codes you can find on this link. And before showing them, I just wanted to talk about one other topic that we have this Discord server for the Hungarian community working with GPU technologies. I know many of you are already members, but those of who did not heard about it before, we are a vendor neutral, a collection of people. You can talk about everything, graphics, compute, different technologies, different vendors, newest graphics cards, whether you are a student from the students at the university, or a scientist or professional. We have some topics for everyone. Please scan the QR code. You will also be able to find it in the lunch hall and join us. And we can talk about all of these technologies. You can ask questions if you get stuck. And I will ask Gabor to show just two demonstrations. This is an audio spectra that is running inside the browser. This is Edge, right? Microsoft Edge. And this is running the FFT, fast Fourier transform, as a compute shader at real time, reading the microphone from the web browser. And we have another demonstration that is this fluid simulation. This is usual, very simple, smooth particle hydrodynamics with the dam break. That is the usual demonstration code. This is again compute shaders and very trivial visualization of rendering a few dots. And yes, of course, it's working on this laptop, but you can open it up on your phone. If you have an Android phone with Chrome, it will work. It is running reasonably well without any advanced optimizations with a few thousand particles real time on your mobile phone in your browser. So thank you for your attention.
Thank you, Donny. Any questions, comments, the audience? Yes, Martin.
Thank you for the nice talk, and that opens a lot of opportunities for us. I would like to ask that, as you have shown how many technologies you have to bring together for that to work, how easy is it to debug? So when you want to analyze your code, what do you provide for that? And another little bit fun question that I have heard of exploits like mining Bitcoins on your browser with JavaScript. Will it make that more efficient? Thank you.
Yeah, good question. I'm not fully up to date on the debugging technologies. I'm sure it will be needed. The underlying APIs are applying validation layers, like in Vulkan. That is the one that I'm most familiar with, that help you catch different errors. I think they will need something also for WebGPU, and I think there are some error and diagnostical API calls that you can use during development to check if you have made a mistake. But surely it's something that is also coming up and being extended. And yes, exploits are always possible. It's always your responsibility what you click on. But as always, you can check in your browser what is being used and how, and you can disable these technologies if you don't want. But otherwise, yes, it would make it more efficient.
You will notice it very soon because it's producing a lot of heat.
Yeah, it's already not economical to mine most of the currencies on your GPU. So
I would have two small questions. The first is that if I have a CUDA code, is it worth to now to no? Okay.
that's so much different technology. But yeah, and it might be using some advanced features that are only present on NVIDIA hardware, right? But these technologies are covering much more wider range of compute devices from AMD, Intel, ARM, Qualcomm, and other manufacturers, and there is just so much difference between what is supported by the device and what is the optimal way of doing something. So directly porting a low level, especially well optimized CUDA code might just not work out of the box, even in theory.
The other question is that other end is that sometimes or most of the times for visualization, for example, the biggest pain is that even for drawing a triangle, you need hundreds of lines of codes, and you are the nowhere. So what is the solution? What are the attempts to go in that direction?
You can expect that some libraries will going to land. I mean, there are already JavaScript libraries that are helping you with higher level stuff. The main point is that now they have a more profound, a better foundation to build upon. They can offer you more features. They internally can structure their stuff more efficiently. So they can offer you features, higher level features like visualization more efficiently, and you will just have a better user experience, even if you are not directly writing something. There was another question somewhere. Yeah.
Thank you. Just a quick one. Do you have any competitors in this space, like anyone who's doing something similar?
What do you mean exactly? Sorry.
For the WebGPU technology, are there some competition?
I think so. This is very development of WebGPU is really tied to the highest level players. So you cannot just pop up with a new technology, a new alternative, right? So it's really tied into the development circles of the web consortium and all the lower level graphics APIs, game studios, hardware vendors. It's mostly like that. So what you can expect is other companies building upon this technology to offer you higher level solutions, integrating with particular other technologies. I don't know, data transfer, audio, video processing, neural networks. So it's like it could lead to an explosion of applications and offerings, service offerings, but not like alternatives. I mean, that's why we had so many dead standards, right? It was very hard to put this together and required so many challenges to be tackled that it's just not something where you need an alternative.
Thanks again. Again, a principal question. So when you have, for example, this code running now, do you have to share the source code all the time? So you transfer the source code to the client?
Everything is running on the client.
Yes, but
the source code is
the source
there.
code.
Yes,
So
it's an IP problem, if that is the
yeah,
question.
I mean, it's a copyright problem. I mean,
exactly. They have not tackled this. Let's just say that API writers tend to repeat the same mistakes all over the years. SpearV was created like this before for OpenCL because it was just plain text and people couldn't package their IP to be a non-readable representation. I think they had to cut some corners and eventually there might be a non-directly readable representation for the shader codes. For the host side code, you can already package it to WSM. That is the binary representation on the web. So you can package the entire application, just the shader source code is still plain text. So it is moderately easy to gather it out if you are looking into a little bit. I expect that there will be solutions to this, but I think for version 1, you are aiming for the minimal viable product. So they had to cut some corners. I think later there will be updates that will handle this. But yes, otherwise you just go there, go to the source of the page, and you see everything.
Thank you. So my question is about performance. So let's assume that I have a large language model, let's say the GPT-2 with 1.7 billion parameters. I can run it on my NVIDIA gaming GPU with some certain performance. The question is that, is it practical to try it on WebGPU? And is there any performance decrease or almost the same?
Yes, the question is good. There are already, I believe, experimental implementations for some language models. I think if you search around, you will find some demonstration projects. I didn't see specific performance comparisons, but for other tasks, people have reported somewhere like 5% or 9% difference between the native implementations, but that was not for large language models. The expectation is that it will stay. I don't expect very large differences, only if there are very deep optimizations happening somewhere there. But otherwise, all of the libraries that are providing frameworks for running all kinds of neural networks or large language models are trying to push this such that they could have a basis to implement the model layers and all the architecture that is needed. So the expectation that it will be competitive, it will be a little bit slower for various reasons, but I think it is reasonable to expect at the same order of magnitude performance.
Sounds cool. Thank you.
You're welcome.
Okay, then I have to contradict you in one point because you were showing us that there is no free lunch, but there is free lunch downstairs. So everybody is welcome there. We will meet at 2 o'clock, so we have 1.5 hours. And let us now again thanks all the speakers for the session.